Hi guys, welcome to my YouTube channel. Today we're going to be doing limits with trigonometry. I hope you enjoy. Please do subscribe. It really helps me. Thank you. Okay, so let's get right into this. Today we're going to be doing limits with trigonometry and the squeeze theorem, and we're also going to be doing limits with logarithms. We'll do, natural logarithms and normal logarithms. And sadly, I don't have a logarithm video. If you do want to learn, just search it up, please. It it's searching up is probably the easiest method. But let's get right into this. What's the limit as x approaches to 0 of sine x over x? Well, if we use the squeeze theorem, we would find out this is 1. And you might be thinking, why do I need to remember this? I can just plug this in. But sine 0 equals 0, and well, if x equals 0, then x is 0. So we get this, if we plug it in, we get 0 over 0, but that's intermediate form. And today we're going to be going over how they proved it, but for now, let's not talk about that. Okay, and I forgot to mention this, but please do memorize the other one, sin x, sine x over x equals 1, since you're not going to get this. They're not going to tell you this on an exam. Okay, let's talk about this. The limit as x approaches to 0 of 1 minus cos of x over x is equal to 0. You might be wondering how someone proved this. We're going to be talking about the squeeze theorem later. So you might be thinking again, why can't I just plug it in? Well, 1 minus cosine of 0 is 1 minus 1, since cosine of 0 is actually 1. And 1 minus 1 is 0, and if x is 0, then we get the intermediate form 0 over 0. But if you remember this, then you'll always know if you ever see 1 minus cos of x over cosine of x over x, it's 0. Obviously, you might not get it handed to you like this, but like you might get 1 minus cosine of 5x or something. But we're going to be talking about methods to do stuff like that later. Okay, so don't forget to continue memorizing all the equations I show. But let's get into the next one. The limit as x approaches to 0 of tangent x over x. The answer is 1, and you might be thinking, why can't I substitute it? Tan x, if tangent of 0 is 0, and if x is 0, then it's 0 over 0. Again, that's impossible. We can use L'Hopital's theorem to figure what if we have an intermediate form like 0 over 0 or infinity over infinity. We can use his method theorem, but for now we're not going to talk about that since that involves derivatives and we're not covering that in this video. Okay, so let's get started with this question. As I said earlier on, they will never just hand it to you. I mean, they might, but they will usually multiply the variable in here by k, as they say in the formula. In the formula, it's sine kx over x. They usually do that. It's weird, but I guess they do it to make it more difficult. What we would do is we would multiply the fraction by 3 over 3, or whatever k is here. So if it was sine 4x, we would multiply the fraction by 4 over 4. Okay? And so we would multiply sine 3x over x by 3 over 3. And what I would do is I would multiply x by 3, but I wouldn't multiply sine 3x by 3. I would make it so it's 3 times the limit as x approaches to 0 of sine 3x over x. You see, we did 3 on the bottom. We multiplied it by 3, so we have 3x. And since after multiplying by 3, it's 3 over 1, and 3 over 1 is 3, so we multiply the limit. Personally, here I would make 3x equal to u. Sorry, 3x equal to u. And since we have that, it's sine of u over u, 3 times the limit of as u approaches to 0 of sine u over u. And you remember this was standard form, and we remember that sine u over u, or sine x over x, is equal to 1. So now that we've taken away all of this, we have the final thing, 3 times 1, and it's 3. So hopefully you understand this. Don't forget to multiply by this fraction, then only multiply the bottom if the top is in the sign here. So you can get the bottom to have the same constant being multiplied by the variable. And when you have that, it'll make it really much easier to assign a value to u. And then using u, you'll hopefully have got back to standard thing like sine x over x, which obviously could be adapted to sine u over u. So let's do a question with the let's do a question with cosine, the rule for cosine with limits. Okay, so as you can see immediately, it's the exact same as the formula, which usually would equal to 0, but x is multiplied by 4. So what we have to do is, as we did last time, multiply it by the fraction, whatever the number before x is, over whatever the number before x is. So we multiply this time by 4 over 4. And then we get 4 times the limit as x approaches to 0 of 1 minus cosine of 4x over 4x. Next, we assign 4x to u. 4x equals u. And don't forget to change it to the limit as u approaches 0. So now we have the limit as u approaches 0 of 1 minus cosine of u over u, and this looks exactly like the formula which we should remember. 1 minus cosine of x over x is equal to 0. And even though it's not x, it's still a variable, so it's perfectly fine. So this is equal to 0. And now we have to multiply. Don't forget it was 4 times the limit as this, because we didn't multiply the top. So now we have 0. So 4 times 0 is equal to 0. So the limit as x approaches to 0 of 1 minus cosine of 4x over x is 0. Okay, so now this question is slightly different. The limit as x approaches to 0 of tangent of x over 2x. Now the denominator is multiplied by 2. So we still multiply by 2 over 2. And we do not we still multiply by 2 over 2, since whatever x is being multiplied by, we multiply it by the fraction of that, whatever x is being multiplied by over whatever x is being multiplied by. So we get the limit as x approaches to, we don't need that. So we don't need that. The problem is when we multiply by 3 over 3, And since the bottom only got multiplied, we divided this by 3. So we get 3 over 1. But 3 over 1 is equal to 3. But now when we do 2 over 2, only the top is multiplied. So we divide by 2, since this has been multiplied by 2, and we get 1. So instead of being multiplied by like usual, like 3, if it's 3 over 3, it would be multiplied by 3. Now it can become a fraction. So we got 1/2 actually. So now the equation is the 1/2 times the limit as x approaches 0 of tangent 2x over 2x, 2x. You remember we would put u as 2x, so u equals 2x, and the limit as u approaches 0. So 1/2 of the limit as u approaches 0 of the function tangent. Of the function tangent of u over u is looking real similar now to, you remember the formula tangent of x over x equals 1. So now we have so now we have 1. So this all equals to 1. And 1/2 times 1 over 1, or it's just 1, is 1 over 1/2. So the limit as x approaches 0 of tangent x over 2x is 0. Now we're going to talk about the squeeze theorem and how we use the squeeze theorem to calculate all of these the limit formulas. The sine x over x equals 1, or cosine x 1 minus cosine of x over over x is equal to 0. Don't forget it always, for all of them, it's the limit as x approaches to 0. So don't forget that. So as x approaches to 0. It only works when x approaches to 0. If x approaches to 1, don't use this. Yeah, but I forgot to say, the squeeze theorem is really important. So usually I would have managed to do it in one day or something, but I was thinking I don't want to, since the squeeze theorem is quite important and it's really useful in proof and stuff like that, geometric proof and stuff like that, I thought I would do a whole video dedicated to it. So if you really don't understand the squeeze theorem, you should be ready for the video. I'm probably going to release it soon. There are two things I forgot to mention before we move on to logarithms with limits. First of all is that just plugging in the values works sometimes. If plugging in the values doesn't work, which is the first thing you should try, always plug in the values first. Try to plug in the values first before, using any other rule. So you see here, the limit x approaches to 0 of cosine x is just 1, because cosine of 0 is 1. And that's quite a big part. Just do forget to substitute. It sometimes works. But what if we have the limit as x approaches to 0 of sine x times cosine x over x? This just looks like sine x over x times cosine x, since you remember the formula which we covered, sine x over x is equal to 1. So we can change this to sine x over x times cosine x. And if we have sine of x over x times cosine x, we get sine x over x equals 1, and cosine of x as the limit x approaches 0 is 1. Cosine of 0 is 1. Here it says x approaches 0. So 1 times 1, and we get 1. So the limit as x approaches to 0 of sine x times cosine x over x is 1. These are some things I forgot to mention earlier that are still quite important. And now hopefully you guys are equipped with all trigonometry for limits. Obviously there is a bit more. There was L'Hopital's rule and the squeeze theorem. But I'm going to make a separate video about the squeeze theorem and L'Hopital's rule, which I probably butchered the pronunciation. It's like, it's spelled like this, just so. L'Hopital's rule, it's, we will cover this later on since it involves derivatives and we have not covered that, and we probably won't be covering that for another few episodes. So, let's get right into logarithms. Okay, now guys, I do understand I'd said we'd cover logarithms in this video with limits, but sadly I did not have the time to do it. So we're going to be covering that in the next video. My next video will be on the squeeze theorem, but after that we'll go back to, the calculus videos. And that's when, in maybe a day or 2 days, that's when I'll release the logarithm with limits videos. Thank you guys for watching very much. I really hope you enjoyed.